All right, thanks everyone for coming here today. I'll be talking a bit about what we've learned building observability developer experience for ClickStack. So a quick background on myself. I'm currently the head of product for the observability product line here at ClickHouse. Before this, I was the co-founder and CEO of HyperDX. This is an open source observability platform that's been built on ClickHouse for a number of years now, and continuing working on that here at ClickHouse. Previously, I also ran developer experience at LogMA, which was basically the CloudWatch product for IBM Cloud, along with a number of other Fortune 500s. So I've been thinking about observability for quite a number of years now, probably more than I would like to admit at the minimum. And of course, Mickey kind of talked a bit about the companies who are using ClickHouse for observability today, but here's some of the logos I think that are really exciting that are using ClickHouse for observability. Of course, ClickHouse is fantastic at working with data at scale, and observability is another problem of data at scale. And that's why a lot of these large enterprises trust ClickHouse for their observability workloads. And we've been really lucky to have a lot of these companies in the past talk about it, and also later today as well. Before diving deeper into our product, I wanted to talk a little bit about why observability sucks, or at least why it sucks today. And this is kind of why we're building a product in the space, right? Is because it's not really a solved problem quite yet. And I think it really starts from talking a little bit about the current state of observability, right? I think a lot of people talk about the three pillars. In reality, that is really just the three silos in disguise. So you start off with the logs being stored in a search database. The metrics, I'm not sure why it says located there, but metrics and other Prometheus or Athanos or some other database as well, and your traces in a third database. And that means correlation is really a disjoint experience. At best, it means those three signals are put in one timestamp, and the engineer is the one correlating it by looking at what timestamp matches up with what. It's not really correlated observability. It's just three systems duct taped together, and that's kind of true across the industry, no matter how much they want to tell you that they're an observability platform. And why we've gotten here is because observability has been historically a series of trade-offs, right? You can either be cost efficient, you can be really fast at searching for specific logs in a pile of logs, or really fast at aggregation for basically building visualizations over billions or trillions of rows. And for logging, traditionally we've chucked them into search engines, right? So this is really great for doing needle and haystack searches. So you have a very specific log message you're looking for. Those search engines are great for searching for those, but they don't have as good performance when you're zooming out. You want to build a trend of how that log message has been trending over time. That's where these search engines really fall apart. And arguably today, a lot of these search engines also aren't as cost efficient as they were many years ago, as data volumes have ramped up over time. So when we come to visualizing this data, we've switched to these metric stores, right? So these are systems that will pre-aggregate all the data at the source and then store it in a specific database built just for metrics. But this means that if you want to go from metric down to the root cause of the original event that caused that metric, you lose that link because it's already pre-aggregated. And again, cost efficiency has kind of degraded from a lot of these metric stores as, again, we've been trying to go towards high cardinality metrics and more time series across more complex infrastructure. So what does this actually mean in practice? So let's just say, for example, we're on call and we're paged at 2 a.m. about increased errors. We go first and check out our metrics data store, and we're going to see, usually a count, like a number. We're going to see the name of the metric, and maybe a few low cardinality labels, like the region it's occurring in, maybe the node that it's occurring in. But overall, it's just telling us that, hey, we're going to have a bad night, but not why we're having such a bad night. And that's kind of where metrics data stores fall short of, telling us why. And then you might take those errors and go search in your search database, your high cardinality database full of probably logs, and you're looking for all the errors that are occurring. And you might be flooded with billions and billions of errors. And it's really hard to understand, what errors are novel and which ones have always existed, right? So just because an error is occurring here doesn't mean that it's actually concerning. Maybe it just always exists in the system, but you can't actually build aggregations on top of this data. What you really need is you need the ability to seamlessly move between the individual rows to find, some sort of interesting, hypothesis, and then zooming out and graphing that out over time to see whether that's a novel trend that's been happening or something that's been happening the entire time and isn't new and useful to your current investigation. So really with true observability, we really want a system that has fast aggregations over high cardinality unsampled data so that you can get to the source of truth without throwing away data or hints that you need to solve a problem. That's still cost effective at scale, so you can actually afford it instead of turning off of it after using it for a year, basically. And really, what I'm saying is that true observability needs ClickHouse. Of course, I'd be saying this at a ClickHouse event as a ClickHouse employee, but please hear me out here. As I kind of said earlier, observability is just another data problem. And of course, ClickHouse has been proven time and time again to be really, really good at data problems. So ClickHouse is incredibly fast. It's known for processing petabytes of data with ingesting and querying both of that in real time. We've heard about this already. It does this by being really resource efficient with high compression ratios. I think Mike showed kind of the 7 or I think like 15x compression ratio on the data that we see internally. It could be much higher than that as well. We also allow for smaller hardware footprints with compute storage separation and compute separation. So a lot of different ways of deploying ClickHouse that is a lot more efficient in utilizing your hardware. And it's also flexible and extensible. It's a SQL, it's a SQL database at the end of the day. So really kind of any question can be posed with ClickHouse and can be answered via the flexibility of SQL. And it supports a variety of ways of getting data in. Open telemetry is certainly one of the primary ways that we recommend. But a lot of companies also run, Vector and Kafka and a lot of other ways of getting data in as well. And then lastly, it's compatible with a wide variety of data formats. So even if you're storing that data in Iceberg or Delta or Parquet, there's a ton of data formats that ClickHouse will work with natively, whether it's on disk or in object storage. Now, this all sounds really good, but something was actually missing for ClickHouse when it comes to observability. And that was really talking about a ClickHouse native user experience when it comes to observability. How do you turn a database into a proper observability platform, right? So that's why earlier this year, ClickHouse has acquired HyperDX. And that's what we're building here and what we announced last month, which is ClickStack. It's the high-performance open-source observability stack being powered by HyperDX as the visualization layer, ClickHouse, as we know and love, as the storage layer, and OpenTelemetry, which is our recommended way of getting data into the ecosystem. But this stack is composable, as Mike has shown earlier. There's different parts, there's different ways you can get data in, as well as visualizing it as well. But this is kind of our opinion way to get started. It's incredibly easy to get set up. It's something you get up and running in just a minute on top of any ClickHouse instance, whether that's an existing one that you already have all your telemetry inside of, or a brand new one set up with a custom schema as well. It's also built for observability from day one. So while ClickHouse is a really great SQL database, what ClickStack allows you to do is you can actually query this your data using a more concise and user-friendly Lucene syntax as well. And then also gives you end-to-end observability into your entire stack. So whether you're monitoring the front-end session replays to the back-end logs to the underlying infrastructure metrics, all that is visible within ClickStack as well. And the whole stack here is being maintained here within ClickHouse. So you know that you're getting the best experience possible out of leveraging ClickHouse's capabilities. And then last but not least, It's OpenTelemetry native, so based on open standards as much as possible. And it's also fully open source, so you can get it started on your laptop today without having to do any extra procurement or anything like that, run on your own labs and all that. And this is, of course, already being used to power our internal observability. I'll skip through this slide because Mickey has already kind of talked a little bit about this. We have a pretty complex internal setup that depends on OpenTelemetry logging into ClickHouse, and then we're able to consume this data within HyperDX. So really, it's kind of, you can think of this as kind of like a scaled up version of what ClickStack is offering today. This is kind of what we do internally. We are using Grafana as well. This has existed pre-acquisition, but we've been migrating over the workloads to HyperDX as our engineers find that a lot more intuitive and also a lot more performant for ClickHouse specifically. So I've talked a lot about observability so far, and I want to talk a bit about the developer experience as well, and kind of like, what are some of the things that we did to build this product to be better than the other ones on the market beyond being powered by ClickHouse. And the one thing to keep in mind is that not everyone is an observability expert. This is something that is really important to us. I think products like Splunk have a quite complex query language, and it's also very bespoke to their specific platform. For us, it's really important to realize that while I probably live and sleep observability, most engineers do not. Most engineers have a product that they're focused on shipping, and observability is a smaller slice of their day-to-day work, and the product should be easy to use for them based off of that. And so a couple examples of this that we provide is, for example, just even our search interface here. The first thing that we do is that we have a really concise Lucene syntax. It's something, it's the same syntax that you use Google for example. When you go Google, you type in the words that you want. You can also do, property value searches as well. It's really easy to remember. It's something that you use every day already. On top of that, we actually have an English explainer as well. So we take what you typed in and we try to explain it back to you in a more kind of plain text language, so you understand how the interpreter has tried to interpret your query so far. We've added UI filters as well, so you can actually just click through on the UI to see, hey, you want to filter by this service, by this level. So you actually don't have to type in anything technically at all. And then we still want to preserve the power user feature of having an escape hatch to SQL. So SQL is a very complex but powerful language. Sometimes you actually need all that power to diagnose something very, very specific that is harder to access via Lucene. So we give users the ability to fully use SQL functions that are available under the hood to get the most complex queries done still without too much pain. The other part is also designing a visualization interface that's kind of easy to get started. So instead of having to write really verbose query language, whether that's Splunk or even SQL to some extent, it's really easy to get started just saying like, hey, I want the count of this specific query grouped by this specific property. So users don't have to be intimately familiar with SQL. They can just kind of click through the interface, pull in a few properties, and then get started building charts on top of that. And the other part as well is being able to comb through a sea of data as well. And we have a lot of different tools of doing that. This is one example, which is event deltas. Basically, what's happening here is that we will graph out operations, how long operations are taking in a heat map format. You can drag and say like, hey, this is an anomaly that I want to investigate. And then you're able to actually see what is the difference between events within that green square and outside of that green square. So basically understanding what are the properties that are driving anomalous spans within your application. So this is just like a tool that gives you kind of almost like a data science-y view of what is going wrong without you having to figure out how to formulate your question in a more complex manner. So basically giving you the ability to find anomalies a lot easier as well. And the other thing is that within ClickHouse or any database, being able to utilize the right indexes is really important to having fast queries. And ClickHouse is no exception. There's ways to write bad queries and there's ways to write good queries. And the idea is that we want to make it as easy as possible to write good queries. So that's why in our search interface as well, we also make it so that the queries that you put in by default we'll try to utilize the indexes as much as possible. So for example, if you just type in a whole word, we'll try to match the whole word index behind it instead of doing a substring search. Users can break out of that and put stars around the text, and then we'll do a substring search. It'll be a little bit slower because as I comb through all the logs, but by default, it'll use the text index to be able to get the data that it needs. Actually, not sure why that one got repeated. It's a straight slide. But overall, there's other things that we do differently as well, is that we want to connect the dots when it comes to an investigation. So instead of having you kind of hunt through logs, metrics, and traces as 3 different products that are disconnected, instead we try to put together all the context in a single place. So this is an example of a failed span that's being co-located with the other span events that are happening, as well as a log. So to give you an example, to give you a context of why something occurred, how something occurred. It also pull out attributes to tell you who it's happening to, or what the target is, and information about, of course, when and what as well. So basically, how do we help answer context around a given event really quickly within our interface, as opposed to having users having to dig through different parts of the product to get those same set of questions answered. And then another part as well is being able to actually connect it all to infrastructure metrics as well. So here it's easily correlate between a given trace and the underlying CPU and CPU usage and memory usage and disk usage of the pods and node underlying that given instance at a given point in time. So I've talked a lot so far. I'm going to run through a really quick demo of the product. So let's see if the demo gods will cooperate with me today. And let's pop open the product. So let's see. Hopefully it's big enough. Okay, great. So this is a view of what the product looks like. You'll see it's live tailing new events coming in right now. So this is just kind of live data coming in. In fact, this is a bit of an old query as well. So this is actually showing off our ability to use SQL as well. So in this case, what we have, your traditional logs, have this text body field here. We're actually dynamically at runtime also pulling out the first number out of it and pulling to its own column. That's something that might be helpful at times if you're trying to dynamically analyze your data. But actually, just for this demo, I'm going to remove that for now, bring it back to the regular events. And one workflow I like to show is that usually you might be responding to an incident or doing a retrospective on an incident, and you want to figure out why there might be a spike in errors. So HyperDX make this really easy by easily going for, hey, find me error events. There's nothing much going on here. But I knew that, I think maybe 12 hours ago, there was a really big spike in errors, and we haven't really figured out why that's the case. And here you can see this is kind of the sea of logs we were talking about before. It's really difficult to figure out what the root cause of this issue is. So we can actually go and use the event patterns to go distill down the different types of errors that are happening. And we can see that very clearly there's this, this Visa cache full error is certainly kind of one of the primary drivers of errors that are occurring here. We can go and click on a specific instance of this error, go and view the trace to see what was happening around this time. So this is, given this one error, here are the other events that are happening around it, so you can kind of understand the full flow of events. At this point in time, we can go and click and view, the error span next to it. In this case, we have some stack trace information available as well. So we can see, some information about the root cause, kind of what's happening in the code level that's triggering this error. And then just to be safe, we could also go check out is the cache full because there is really high memory usage and it's maxing out the memory for the pod. In this case, it's certainly not. The memory usage is pretty flat. There's nothing interesting happening there. The pod's pretty healthy, so you can't go and blame the infrastructure team. In this case, it's definitely your fault as an application developer. But it kind of gives you the ability to really understand that data really quickly here as well. And I think I probably have another demo here. Yes, so the other thing that we do as well is we also have the ability to do session replay from front-end monitoring as well. So it's really easy to be able to go from a front-end event down to, let's see if this one has an error, or let's see if this one has an API request. So it's easy to go from a front-end session to view kind of what was happening, what was the user was doing, to be able to click on a specific network request that was made from the browser and then be able to trace it all the way back to the back end as well. So you kind of get the full ability to visualize the journey of an event from the browser, what the user is doing right before that, all the way back to the back-end logs and traces and metrics associated with that as well. And then, let's see, I think, yeah, and then one more around kind of like the event deltas is kind of just showing like, be able to build a heat map over how long events are taking, and then be able to kind of like quickly view what are the different inliers and outliers between the anomalous events and non-anomalous events as well. So there's a lot of other features. I won't go into all of it. You can go, there's a lot of other features that are supported. There's a lot of different features kind of supported in ClickStack in general. I'll have a link at the end of the presentation where you can go check out a lot of these features and play around with it yourself on your own computer if you would like. Of course, there's a lot of features that we're working ahead for ClickStack. So one of it is, of course, integrating with ClickHouse Cloud. If you're using ClickHouse Cloud, this will become more of a managed, there'll be more of a managed experience. So while it's open source today, you can deploy it on your computer. We also want to make it really easy for you to be able to use it in ClickHouse Cloud and also have it more spun up as a vertical SaaS offering, whether it's called ClickStack Cloud or something else. But you can imagine a more simplified offering where you kind of get observability as a service. And then also there's a lot of things around anomaly alerts, observability agents, prime QL support for metrics, and a lot of other features on the roadmap as well. It's certainly kind of a lot of exciting features we're excited to announce for later this year. So you can get started today by checking clickhouse.com/O11Y or the observability use case on the ClickHouse website. There's a lot more information there that you can take a look at. Awesome, thank you.